Hello, this movie is for Unit 6, Learning Target 6-7, Properties of Rectangles, Rhombuses, and Squares. A rhombus is a parallelogram with 4 congruent sides. A lot of people call this a diamond, but you have all 4 sides congruent. A rectangle, you don't have all 4 sides congruent, but you do have all 4 angles congruent. And a square gives you both all 4 angles congruent and all 4 sides congruent. Knowing those properties, could you put the following, a square, rectangle, and rhombus, into this Venn diagram, where the overlap here is one of the polygons that is both of the other two? Pause the movie, try that, press play when you're finished. Okay, what we see is that a square has properties of both a rectangle and a rhombus. So if this is a rhombus, where all 4 sides congruent, and this is a rectangle, all 4 angles congruent, a square meets both of those conditions. It's got 4 sides congruent and 4 angles congruent. That is a symbol for parallelogram. So it's telling us it's got all the properties of a parallelogram. Is parallelogram ABCD a rhombus, rectangle, or square? So we're looking at ABCD. What I've got here is I've got B is given as a right angle. Because ABCD is a parallelogram, I know opposite angles are congruent. So D is also 90. Now I also know consecutive angles are supplementary. So if this is 90, then this has to be 90 because they add up to be 180. And opposite angles congruent, so I do have all 4 right angles. But I can't get all 4 sides congruent, so this is a rectangle since there are 4 right angles. What about EFGH? This is the got it part. Is EFGH a rhombus, rectangle, or square? Now, is it telling us right here? It's telling us it's a parallelogram. So all of the properties of parallelogram hold true. So looking at EFGH, we have these 2 sides congruent. What we know in a parallelogram is opposite sides are congruent. So these 2 would be congruent, these 2 would be congruent. We know we have all 4 sides congruent. Can we get all 4 angles congruent? No. So the best that we can do is say that this guy is a rhombus because there are all 4 sides congruent, but nothing more. Okay. Next, we're going to try to maneuver this page here. Hold on. We've got 2 theorems. If a parallelogram is a rhombus, then the diagonals are perpendicular. This is really important to remember. If you have all 4 sides congruent, then the diagonals, which connect the opposite vertices, will hit so that they are perpendicular. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So this diagonal is making it so that angles 3, 4, 7, and 8 are congruent. And this diagonal makes it true that 1, 2, 5, and 6 are congruent. Bisects each of the angles. We're going to skip this proof, so go ahead and cross that out. We're going over here to this slide. What are the measures of the numbered angles in the rhombus? So we're given that it's a rhombus, ABCD. So what we have here, with it being a rhombus, we know that this is 58. Well, if this is 58, then this is as well. And what we know is that opposite angles are congruent when you have a parallelogram. And because we have a rhombus, we know that we have a parallelogram. So therefore, 3 and 2 are also 58. So the measure of angle 3 is 58. The measure of angle 2 is 58. Now that I can put in 58 here, the other property we remember about a rhombus is that the diagonals hit at a 90-degree angle. So if that's 90, what's the measure of angle 1? 90. Then, how do we get angle 4? Well, we've got a triangle right here. So we can solve for the measure of angle 4 by doing 180 minus 90 minus 58. And we get that the measure of angle 4 is 32. Let's try the next one. Pause the movie, try this on your own, press play when you finish. So we're given that it's a rhombus, PQRS, and we want to find the measures of angle 1, 2, 3, and 4. So this is 104. What we know is that this diagonal is bisecting these angles. So these are congruent and these are congruent. So if I set these each equal to x, I know in this top triangle that the 2x plus 104 should equal 180. So then I get 2x equals 76, and I divide by 2, and I get x is 38. So with x being 38, you can see that all 4 angles will be 38 because diagonals bisect opposite angles. If a parallelogram is a rectangle, then the diagonals are congruent. This is a big one. If you have a rectangle, then you know that these diagonals will be the exact same length. What's really cool is because a rectangle is a type of parallelogram, and you know opposite sides are parallel, and you know the diagonals bisect each other, it means that all 4 of these sections are congruent because you have a rectangle. In this rectangle, so we're given that it's a rectangle, SF is equal to 2x plus 15, and RB is equal to 5x minus 12. What is the length of the diagonal? Well, you only have to find one because they're congruent. So what you do is you set these two guys equal to each other, and you solve. You get 3x there, add 12, and you get 9 is x. So if 9 is x, what we can do is plug that back into one of these, here and here, and get what SF is, as well as RB. And what you get is 2, 9, 18, 15, 3, 33. So it's D. They're each 33. Diagonal lengths. Pause the movie, try this one on your own, and press play when you finish. Alright, you've got ln is 4x minus 17. MO is 2x plus 13. What are the lengths of the diagonals in the rectangle? So you're given that they're equal to each other in this rectangle. So 4x minus 17 equal to 2x plus 13. So we solve it in 10, and then we divide by 2. I get x is 15. And it says, what are the lengths of the diagonals? So we got to plug that in here and here. And so you get that ln is 4 times 15 minus 17. ln is 43. So both diagonals are 43. That's part A. Part B, what type of triangle is triangle PMN? PMN is this triangle, and because it's a rectangle, we have the diagonals are congruent and they're bisecting each other. So this is true. And so in looking at that yellow triangle, you get an isosceles because the opposite angles will be congruent. So what we have here is that triangle PMN would be isosceles. And that's all for this movie.